Everyone, welcome back to EGR 250. So this time we're going to be doing another problem. This time with not our nice two-force members, but with multi-force members. Thunderclap, thunderclap, thunderclap. Very, very scary. So what it says is a strut having a mass of 40 kilograms per meter. Okay. That's not a weight there, that's a mass. It's supported by a cable, as shown. The structure supports a block having a mass of 500 kilograms. Find the magnitude of the reaction force at B, okay, right here. On the magnitude in newtons. I mean, you like to bias the cable. Cable, no mass. Strut, mass. Okay. So, there is some sort of reaction force at B. Now, as usual, the first thing we have to do is see if we can solve everything using our nice equations. Ooh, that doesn't look very nice. Let's see if I can make this work. Okay, so first off, it has a weight. The weight is right here. And it's 40 kilograms per meter, and it is, well, it's a triangle. It's 12 this direction, 5 in this one. So the square root of 25 plus 144, that will equal 13. So this guy is 13 meters long. And so the mass will be equal to 40 times 13, which is equal to 520 kilograms. And the weight is equal to mass times gravity. It's one of those things you have to remember. We had this equation a long time ago. That'll be 520 kilograms times 9.81 meters per second squared. Okay, let me plug that into my calculator and see what it pops out as. You didn't think I was doing this from a solution, did you? No, not me. I actually had to plug this in the calculator today. Okay, so times 9.81 equals 5,101.2. Okay, coming back to you. So that will equal 5,101.2 newtons. Newtons. So 5,101.2. And now what is the weight caused by that 500 kilogram mass? Well, that's going to be mass times gravity as well. So 500 times 9.81. Let's see what it comes out to be. So clicking it again, 500 times 9.81. 4,905 newtons. Okay. So that right there is 4,905 newtons. Okay. So, with that, we have to try to solve. But sadly, it's not always that easy. Things never go quite like we hope. And we don't probably have enough equations to be able to solve everything. In fact, I'm sure we don't have enough equations. But we'll figure it out. We'll still get this eventually. Eventually. Okay. So, with that in mind, I'm going to erase my work down here because I need the space to do some more stuff, some more magic. So let's see what we can figure out just from our three equations looking at this free body diagram. Before I get into that, I'm going to need to put my components. I got some of the forces in the y. I got some of the forces in the, sorry. I got by here. I also have a bx. And I have probably two components of this one. I have a cx and a cy. I'll draw that one in the opposite direction. There we go. cy. Okay. So, some of the forces in the x are equal to 0. I only have two forces in the x. That would be bx plus cx, which means that bx is equal to negative cx. Okay. That makes sense. I got no other forces in the x direction. Now, forces in the y direction. So the forces in the y is equal to 0. Is equal to by plus cy both pushing up, minus 4905 minus 5101.2. You know what? Just for the sake of my sanity, we're going to make that 5101. Okay, and that equals 0. Therefore, by plus cy equals, and let me see here, that would be 4905 minus 5101. Do my math in my head here, people. Would be 11,006, I believe. 10,006. That's why you have to be careful. 10,006, which for the sake of sanity, and also because this is EGR 250, we don't want to go that many decimal places, or any significant figures. So 10,000. Okay, newtons. Okay, then finally, sum of the moments. Well, I gotta choose B or C, or A. I can do it anywhere I want, really. But what would make the most sense is to choose a point where I can solve for something. And so I'm going to take the sum of the moments about point C, because I don't care about C, but I do care about B. So having done that, come on. Oh, you going crazy, man. Here. Okay, doing the sum of moments around C. Take into account all the forces except for those at C. So that would be, well, I'm going to say that clockwise moments are positive. And so that would be Bx times 7 minus 5101.2, and that's at the center of that beam. So that'd be 6 meters away. And then minus 4985 times 12. That's equal to 0. Okay, let's plug that into a calculator and see what we get. So 5101 times 6 plus 4985 times 12. Okay, that comes out to be a big old number. Oh, I made it too big. Here we go. That's 90,426. And then we divide that by 7. That comes 12,918. $12,918. Not shushing you, shushing baby. It's okay. 12,918. Now, with that, I can solve for CX. So that means that CX is equal to 12,918 as well. It's just I pointed it in the wrong direction to start. It should have been going this way. Okay. And now I'm about to show you some magic. You're like, how can he do magic? More magic than we've already seen? Yes, magic. Because I can do one other equation here. And it's all because this right here is a cable. And since it's a cable, it can only be a two-force member. The force can only go along this direction. You're saying, okay, I'm tracking with you, but I'm not tracking with you. That's okay. It's a two-force member, and if you know one component of that force, you know both components of that force. And I know that this is 12 and this is 12. It goes 12 feet down, 12 meters down, and 12 meters over. So its slope is 1 to 1, which means that if the x component is 12,918 newtons, then the y component is also 12,918 newtons. As long as I've done my math right, which is always questionable. So, from that, cy is equal to 12,918. And it would still be going up. At least it should be. Let's see here. Yes, it would be going up because it has to go the same direction as x. Because you can't push on a rope. Sorry. Okay. So with that, I can go back and solve my other equation. So by plus 12,918 minus 10,000 is equal to 0. Therefore, by must be equal to negative 2,918 newtons. Okay. That's enough for me to solve. So b would then be equal to square root of bx squared plus by squared, which is going to be equal to the square root of 2,918 squared plus 12,918 squared. Okay, and using my handy dandy calculator, which isn't always so handy dandy, times 1,298. Okay, and I take that all to the square root, which is somewhere in here. It'll be 13,243 newtons. 43 newtons. Is that correct? I hope so. If it's not, tell me, I'll give you extra credit. Okay. 13,243 newtons, and we've solved it. And just as a reminder, the reason I was able to solve it so quickly there, and I didn't have to do any other equations, is all because, I'm pulling things down, it's because a rope is always a two-force member. Rope is always a two-force member. And so since I knew one component of that force, and I knew the slope, I knew the second component. Okay. With that, I hope this helped you. And if you have any other questions, please email me and I'll make some more videos. Look forward to seeing how all of you are doing. Have a great day. Bye-bye.